We have a sequence of numbers here that we're adding. So this is actually a series, and we want to write this series in sigma notation or summation notation. So our goal is to end up with sigma here that's going to represent this series. So first we have to figure out what's our general formula for this particular pattern. So what's happening? So remember, the first term here is 4. That means when n is equal to 1, the term is 4. My second term is 8. So when n is equal to 2, I get an 8, and so on. You can see here my third term is 12. So sometimes it helps to write down your first, second, and third terms because you can see how these terms relate to n equals 1, n equals 2, and n equals 3. So in fact, in this case, you can see that we're always taking the n value and we're multiplying it by 4. 4 times 1 gives us 4. 4 times 2 gives us the second term, which is 8. 4 times 3 is 12, and so on. So that allows you to get your general formula, which would be 4 times n, if we're starting with n is equal to 1. In other words, we're going to plug 1 in, we'll substitute in 1, 4 times 1, and that gives us the first term of this particular series. So now we need to determine what number we would have here on top of sigma, meaning this is the last value that we'll substitute in. That will give us the very last term in the sequence. So if the last term here is 24, then we would want to substitute in a 6. Substituting in a 6 will yield the last term, which is a 24. So this is one way to write this particular series in sigma notation. But notice, this isn't the only way to write it. This is not unique. There's multiple ways that would be correct. So let me give you a couple of the other options so you can see what the other options might be. For example, let's say you didn't want to start with an index of 1. Let's say you wanted to start with an index of, say, 0. Well, you'll notice that the pattern is still the same. Our pattern is that we're basically adding 4 each time. We're adding 4 repetitively. So let me demonstrate this a different way. We can say, oh, to go from 4 to 8, we are adding 4. And from 8 to 12, we're adding 4 again. And 12 to 16, we're adding 4. So our pattern really is that we're adding 4 repetitively. And that supports why we would begin with 4 times n. If we're adding 4 repetitively, that shortcut would be multiplication 4 times n. But we'll notice if we were to substitute in 0 here, 4 times 0, we would end up with 0 as our first term. But we don't want the first term to be 0, we want the first term to be 4. So to fix this, we could go ahead and add 4. In other words, if I have 4n plus 4, and now if I substitute in a 0, I'll end up with 4 times 0 plus 4, which will give me then 4 for my first term. So if you were to start at 0, you have to adjust your formula, basically, rather than your formula being just 4n, it would have to be 4n plus 4. But likewise, we'll also have to adjust then the value that we would end with. What's my last value that I'm going to substitute in here that will give me the last term in the sequence, which is 24. So you could think about this in your head or actually do a little bit of algebra here if you wanted to. You could take your formula, 4n plus 4, and go ahead and set it equal to 24 and solve to see what n value you'd end up with. So solving this, you'll end up with 4n is equal to 20, and you can see that yes, n should equal 5. And again, you wouldn't have to show that algebra. You could certainly figure that out by just thinking about what number you would substitute here in place of n that will end up giving us a result of 24 for our final term. And 5 makes sense because 4 times 5 would give you 20, plus 4 more would give you the 24. So here's another way of writing the same exact series in sigma notation. And in fact, let's go ahead and write one more just for the heck of it. We could also, if we chose to, start instead of 0 or 1, let's say we started at 2. So we still have that same pattern of adding 4 repetitively, so we'd start with 4n, but this time you're thinking, okay, I want to substitute in a 2. 4 times 2 would give me 8, but I don't want 8 for my first term. I want, again, to have 4 for my first term. So that would have to be 8 minus 4. in other words 4n minus 4, would work for my general formula if I were to start with n is equal to 2. And again, same thing, we need to determine what's the last value that we would substitute in to this formula that would give us 24 for my final term. So you could go ahead and do that algebra again. 4n minus 4 this time is equal to 24, or 4n is equal to 28. So in this case, n would have to equal 7. So 7 would be the very last value that I would substitute into my general formula here. That would give me the last term of the series, which would be 24. So here you have actually 3 different ways of writing this particular series in sigma notation. And there's an infinite other possibilities. These are just 3 of the common ones. So here's our second series that we want to write in sigma notation. So once again, we need to begin by determining what's the formula for the general term, we call it. So if you were to start like we did on the last one, you might say, my first term here when n is equal to 1 is 22, my second term when n is equal to 2 is 19, and so on. But this one might not be quite as obvious as the last one. Last one we were just multiplying by 4 each time. Maybe this one is not quite as obvious, the relationship between n and the actual term. So let's go ahead and abandon that, and let's instead think of the actual pattern that's taking place. So in other words, how am I getting from one term to the next? So from 22 to get to 19, we would need to subtract 3. And from 19 to 16, we subtract 3 again. So you see we have this repetitive subtraction. We're subtracting 3 each time. So a logical place to begin, then, would be to begin with negative 3 times n, since we have that repetitive subtraction of 3. So let's go ahead and start this first one. We'll say we'll start it with n is equal to 1. So now thinking about this, if I were to substitute 1, I would have negative 3 times 1. In other words, I'll have negative 3. But I don't want negative 3 as my first term. I want 22 as my first term. So you have to think to yourself, what would I need to add here? Negative 3 plus what number would then give me 22? And so that would be negative 3 plus 25. Negative 3 plus 25 will give me 22 as my first term. Therefore, my formula would need to be negative 3n plus 25 if I were to begin with n is equal to 1. And if at any time you were unsure whether this formula worked, you would just go ahead and check it by substituting in, let's say, the second here. My second term is 19, which would be substituting n equals 2. So you could just verify negative 3 times 2 if I substitute 2 in for n, and see that you do get 19. So here I'd have negative 6 plus 25, and you can see, yes, that's definitely going to give me 19, which is my second term. So that looks great. All right, so now we need to determine what value I would need to substitute in last to get me my last term. So again, we're talking about what value I would have here on top of sigma. What number am I going to substitute in place of n that will give me 10 for my final term? So if you want to actually do that algebra, you could take your formula, negative 3n plus 25, and set it equal to 10, and figure out what is n, solve for n here. So negative 3n is equal to negative 15, and n would therefore equal 5. So 5 would have to be the last value that I would substitute here in place of n. And if I did substitute 5 in, I would get 10, which is the last term of this particular series. So here's one way of writing this series in sigma notation. So let's look at some other options, because remember there's actually more than one correct answer here. So we'll say, or, what's another option? Let's say we wanted to start with n is equal to 0, rather than n is equal to 1. Well, we still have our repetitive subtraction of 3, so a logical place to begin, again, is negative 3n. Let me go ahead and move this over a bit for us. I'll come up here. So we can start with negative 3n, This time, remember, we're wanting to begin with our index of n is equal to 0. And then think about what's happening. If you substitute in a 0 here, negative 3 times 0 will give us 0. But once again, we want 22 to be my first term. So you're thinking, what number do I need to add here so that I'll get 22? Well, 0 plus 22 would give me 22 for my first term. So negative 3n plus 22 would be my formula if I want to begin with n equals 0. And then again, what value would I need to end with? What's the last number that I want to substitute in? That will give me 10 for my final term. So solving negative 3n plus 22, we want to get 10 in the end. We can solve here for n, and we'll get that n is equal to 4. 4 would be the very last number that I would substitute here in place of n. And if I did substitute in a 4, I would get 10 for the final term of this series. So once again, we could repeat this for various index values, starting at 0, 1, 2, 3, 4. We could really pick any positive n value, any whole number for the index, and then we would just have to adjust our formula on the right-hand side of sigma, and of course our value on top of sigma, the very last value that we would be substituting in.